Our society evolves extremely quickly, and staying up to date can be hard. A new area has recently been developing, 2 or 3-dimensional machines. But what are they, how do they work, and can we do them by ourselves? So let's try to answer to those questions in this video. There are plenty of types of machines: CNCs, 3D printers, plotters, laser cutters. All of those work pretty much the same way. You need to control 3 axes: the X, the Y, and the Z. The most common way of moving the head inside of the space is using stepper motors to precisely arrive at some coordinates. To start off, a CNC works in 4 main parts. First, you convert an image to a language called G-code. G-code stands for Geometrical Code. It's a programming language for CNC that instructs machines where and how to move. Next, you need a software called a gearball controller, capable of taking the code and converting it into commands that will tell the MCU how to move the steppers according to this G-code. Then, you need an MCU capable of understanding those commands. In my example, I will use an Arduino on which I have flashed a hex code to do exactly that. And finally, the drivers that control the energizing sequence of each phase of each motor. With that out of the way, I wanted to build a small-scale prototype to show you the basics. The next section will explain you my process and the errors I ran into while creating them. Inside the DVD reader, you can find a stepper with his shaft attached to a carriage. This is perfect for our project, so I disassembled 3 of those to have one for each axis. Then after that, I checked the polarity of each motor and assembled a circuit on a breadboard. I used the A4988 driver. You control the stepper using only 2 pins, the direction and the step. This done, I went to my computer and installed the gearball controller and flashed the hex code on the Arduino. And I was ready to test it, so I powered first the Arduino and then the motors with an external 12-volt power supply. But before pressing anything, I had to adjust the amp limit on each driver, and then I tried to controlling the steppers with the directional arrows. So this stage took a very long time, because I had problems such as the motors that were running hot or emitting high-pitched noises. At the end, I was happy with this result, and so I assembled a sort of case in wood to hold the axis. A quick warning: if you want to build this, you need to be careful about the alignment of the axis by looking at the stepper motor's shafts. I also 3D printed some parts to hold it together. Before uploading anything, I had to figure the step resolution for each axis and then configure this in the settings of the gearball controller. Finally, I installed Inkscape and converted an image to a G-code, and then uploaded it to the gearball controller and ran it. So this might be the part that I struggled the most with, and you can see that on the only and best result I could achieve. But never mind, for me it was a great experience, and it pretty much works as a proof of concept. Everything will be available in the description, so you could improve it if you want. Even though this was a different video, I hope you've enjoyed it, and I will see you next time.